G'day everyone. So my name's Adrian. Nice to meet you everyone. So I work for a company called Contexti and we're big data engineers, as I'm sure most of you are. And so I specialize in big data, and today I'll be talking about how my version of big data is how I use partitions to help me. So first thing is, when I talk about partitions, the question is what do I mean by partitions? So I'm trying to pitch it at a wide audience, and so when I talk about partitions, what I really talk about is a bucket of data. And so you can imagine that as a data engineer, you're trying to sift through a sandpit of data, and if I could only put some of that into a bucket, it's going to help me in a long way. And so it's not just one bucket, it's lots of buckets. So if I'm trying to sort through all of the data that I could have maybe 10, 20, 100 terabytes of data. And obviously, if I'm looking for the records for yesterday, it might take me a bit of time, right? So if I had it all in a bucket by day, I can look for the bucket that was from yesterday and it becomes trivial. I can go get that data and it becomes a lot much easier for me. Obviously, I want to put a bit of thought into this. So, if I wanted to pick all of the yellow marbles from yesterday, I could have a bucket inside of a bucket, right? And so you can imagine that if I was to be a bit smart about how I was to put my sand into my bucket, I could naturally sort it, have buckets inside of buckets, and then by the end of it, if all I wanted to do was find the yellow marbles from yesterday, I can go to the bucket from yesterday and pull out the yellow marbles. I can do this for last month. I can pick all the yellow marbles from last month. And so that's kind of what I mean by partitioning. So some people may or may not know what I'm talking about. So in this particular example, I partition it by date, but you can do whatever you like.
How does that trick work?
Magic. No one knows how Hadoop works. There's 30 things. Only my head of platforms, Scott, would know how it works. So the question becomes, when do I use partitions? So you can imagine that, if I had a million of these buckets, it becomes like putting my data in a teacup. I'm going to search through a million teacups to find handfuls of marbles. And if I want everything from yesterday, it'd be 1,000 teacups, and it becomes, the cost benefits, break up. So really when I use partitions, it's when the query takes too long. If it's only 100 megabytes in that bucket, in that table, I'm not going to partition it. If it's 100 terabytes and it takes me, an hour to just select a couple of records, I'm going to put into buckets and it's going to help me a lot. Generally, it's you partition on what people are searching for. So you can imagine that if all I'm looking for was transactions from last year, I would do it by transaction date. If I'm doing everything by state, I would partition it by state, or just something that's meaningful. So we use it for our loading process, and we use it for querying. So the other cool thing is that, by putting it into a folder, it kind of gives it some information. So if the file that I have is just a text file, and I want to say, give me all the text files from yesterday, the file doesn't have the information from yesterday, but the bucket has some sort of metadata, say, well, it was from yesterday, and I can search and get it for it. So when the columns that I don't have, I can artificially generate it. When not to use partitions. So I'm a consultant, a lot of horror stories, going to clients, and a few smirks on our faces. Yeah, it happens all the time. So let's say I want to do stockbroking data, and there's 2,500 ASX codes, and the data engineer decided to do by ASX code, by year, by date, and that ends up being thousands of partitions every day. And you can imagine that over the time, it'd be like millions of partitions at the end of the couple of years. So generally, we advise less than 10,000 partitions. Like if you're going to sort through 100 terabytes, you're going to put 10,000. In my experience, it's about 40, 50,000. Scott's probably, my head of platforms is probably a bit more conservative. I'd say about 40, 50,000. If you're going to do anything more than that, just rethink about how you're going to do it. Show of hands, who uses BigData? One, two, couple, half the room. So for people who if you're using BigData, normally you don't really get to do the engineering side of things. Normally you're a user, and normally it's kind of, I'm querying a table. Give me everything from yesterday, give me everything by the state, or show me the transactions. So some people don't actually know that there are partitions underlying the data, and if only they could use them, it would make their job a lot quicker. Instead of searching for 100 terabytes to get those yellow marbles, I can just use a partition. It becomes a lot faster. So there's a quick little thing that I can do, really easy, just show partitions. And that will show me exactly what that table is. So I'm using that table every day. It's really quick. Now, you can imagine that if I have a lot of partitions, I want to be able to search for that. And so when I use that partition load date, transaction date, state, or whatever it might be, it actually cuts the partition. So if I say, give me everything for the last 3 months, it is going to partition prune and going to give me the last 90 buckets. Super quick. And if you've got hundreds of terabytes, you can see how this would make things a lot quicker. Those who do group by statements, basically if I want to sort by a particular column, the sorting actually happens in a distributed fashion, happens in each bucket. Instead of sorting through everything, it does it within the bucket. It makes things a lot quicker and a lot easier. So if you're going to query your data, be sure to use your partitions. So it's really about how you are going to use the data, mostly. So the general patterns that I see when we talk about data ingestion, so a lot of the data engineering work that we do is all about, obviously getting a file, pulling an API, getting some sort of data out from a source of truth, putting it into our system, doing some sort of transformation, and then having some sort of curated model aggregate table that people can use. This is basically our job as data engineers, and this is what we do every day. So for the raw, our partition has to have a different sort of criteria than what our curated. The curated is like what people are searching for. For my raw, I really care that I have to fix mistakes, and it happens all the time. People give you the wrong data, data is late, a whole bunch of things can go wrong. So for me, I really care about, I want my raw data to be raw. I don't want people to, it doesn't want to have a version, I want it to be the file. So if someone says, you gave me the wrong data, no, sorry. You gave me the raw data, it's unchanged. All I've done is I've organized it into certain buckets, and those buckets help me get the file that I need. And that forms the basis of what we call a data lake. I want to keep all my raw, and then I want to transform and have my curated. The curated, like I said, has to have, different features, and it's more so I can access the data. Without getting too detailed, I'm going to get really detailed later, but without getting too detailed now, basically what that means is all we're doing is saying we normally have to specify what the DDL is, and all I've done is I've added this one line and say, well, it is partitioned by this particular column, and Hadoop will magically just do that in the background. Few things about this. So this is saying, well, I've got a CSV or a tab. This particular example is a tab separated file, and I'm saying that this is a raw file. It's tab separated, and that's what it's partitioned. Skip the header, and I can actually query that. So it's not always CSVs and tab separated. It's not always nice data. Sometimes I get rubbish data. This particular example is from, this is just the open API. So this is from the ABR. So all your ABN records, instead of going to the ABN lookup, you can do an API query. Gives you this really nasty JSON. People have different companies, organizations. Some have GST exemption. And so it's not like a CSV that has 11 columns. This is unstructured data, and I don't really care about what that data is. I just want to put it in raw, and I want to deal with that later. My transformation, let my analysts work out how they want to chop and pick that data. But as an engineer, I just really care about that the process works, that the data lands in raw, it gets transformed, and it's in a format that people use. In this particular case, for the ABR, for people looking at their tax records, it's all about when that file was updated, and people query it on state, so that's what it's partitioned by. And so if I'm getting something every day, and someone goes to me, that file that you gave me on the 3rd is wrong. What do you mean it's wrong? Well, I have to redo it. So they give me a new file, and I would replace that partition. So for me, it's really important that my raw is based on load date, and I don't change the raw. So it's a virtual column. What if I have multiple times a day? So not in the ABI, it's not, but in other cases, like I'm going to get files every day. And so for me, I want to ingest it by the date, so I can do some cool things like give me yesterday, give me the last 30 days. But I also want to do it, if I'm doing it multiple times a day, I want to do a timestamp, so I can have a number instead of a string, so I can do cool things like sorting it. And you're going to see how I'm going to use this number to do upserts on Hadoop and just do some So in my experience, I feel that a combination of a string for like a date and an integer, really, I can do most things in raw with that. What if I want to do it multiple times an hour? So every 5 minutes, going back to that thing, 315,000 partitions. If that table's only got 100 gigabytes, that's close to 300 kilobytes per partition. That's less than the size. We're talking back to that teacup stage. If it was to be 100 terabytes in that table, it would be about 300 megabytes per partition, and that's the block size of Hadoop. There's no benefit by Hadoop naturally puts it in 128 megabyte blocks. By us making that many partitions, it has no benefit. So the answer to that, if I want to do it more than one time, I just append. I keep an hour, and I'm going to put every 5 minutes into that hour, and the next hour, I'm going to do it to the next. Just don't over-partition is the moral of the story. I did say upserts on Hadoop. I had 2 questions before, and yes, we do it. For those who didn't have their hands up, the reason why BigData is so fast is that it doesn't deal with grains of sand. Well, it does, but it doesn't do it when we're writing the data, and it doesn't do it when we read the data. What it does, it keeps it in 128 megabyte blocks, and that way when that hard drive hits the place that it needs to read, it can scan through 100 megabytes super quick and get your data. So we're designed to write once and scan through the data. The problem with that is that I can't change an individual byte block or a record. I have to change blocks. So I'm going to try and explain this, but it's pretty cool. So just imagine that I've got a whole bunch of records for today, and I've loaded it by the day that I've received it. Now, for simplicity, my transactions are ABC. So it was the last 3 days of transactions. And so I've got some records. So someone stuffed up the Tim Tams. So they're doing transaction level data at a shopping center or at a retailer, and they've stuffed up the Tim Tams. So I've got all my records from today, and I'm going to get the ones that need to be changed. What I do is I take everything from today. I take all the records that exist in my today. So everything that exists in D, everything that exists in B. I'm going to combine them. I'm going to do a crazy little windowing script. And magically, I'm going to take all the ones that are the current ones that are registered by 1, and I'm going to override it. And so you can imagine how that will allow us to rewrite some of these things. We're talking about a write once file system. People in a database world are just looking at me like, isn't that just an upsert? But in Hadoop, it's a little bit more complicated. A lot more complicated, actually. So don't ask me how this works in the question. It's just magic. What you want to know is that you get the raw and you union it. The real beauty is this, that I'm actually doing this partition pruning. I'm only selecting the distinct load dates that exist in my thing. In our case, it was the B and the D, but there's no D. It only gets me the Bs. Magic. That row number at the top actually gives me the 1s and 2s. So in our case, if there's 2 files that have the same file date and everything's the same about them, or if I get an old file and a new file, it's going to get the new file date because it's ordered by file date. If I get 2 of the same files, well, then I can't organize it on the file. Then I organize it by so that the most recent file gets updated. So in a way, it kind of does a few cool things in that one little script. I'm going to upload this. Happy to share it. Now the question I get all the time is like, so one second, you're telling me that you're dealing with hundreds of terabytes and you're going to shuffle and sort all of those things. Let's say if I wanted to do a stock take on Tim Tams for the last 6 months, does that mean I have to do 50 terabytes? Or 5, whatever that is? It gets more complicated. I'm so sorry. All these RDBMS people are going, can it be not easy? But it actually gives us some flexibility. And so what we're going to do here, this is actually a pretty cool thing in Hadoop. It lets us do things at the terabyte scale. And what we do here is I get everything from 2 days ago. I get all my Bs. And what I do is Hadoop is really good at scanning through that data really quick. And so for me to just pull out those Tim Tams is really trivial. And I'm going to put that into that windowing table. The second thing that I'm going to do is I'm going to take all the records that do not need to be updated. All the ones that don't have an asterisk, I'm going to get these Ds, I'm going to put into my final. I'm going to get that, if that's 50 terabytes, I'm going to put 49 terabytes into my final table, and I'm not going to have to shuffle and sort that. I then put the output of my windowing function into my final table, and then I upsert it. Exactly the same as before, but I have these in various forms running in different clients in production every morning, every day, and people can do, they can do stock take, whatever they like, and it would just damn work. It's pretty cool. And so we start to see a general pattern emerging when we do our data engineering. So obviously I prefer to do my raw data by load data and ingest time. I've explained my rationale. For those who have on-prem clusters, it's kind of like saying I have a local computer. You must keep your files locally. But for people who live in the cloud, you can either keep it on the computers that are in the cloud, or you can have it on S3. And so that's basically really cheap unlimited storage. So generally, I keep all of my raw data on S3, and then my curated on the local machines. The curate is transformed, and you can partition it however way you like. So can I use S3 for curated too? Absolutely. So there's no reason why I can't do, all of my raw on the cloud and all of my curated on the cloud as well on S3. And so the trick really comes from your boss or your client who doesn't really know the difference. Got a couple of smokes, sorry. So sometimes you want to keep, for whatever reasons, you want to kind of keep a buffer on your local machine, and for everything else, the last 5 years of data, you kind of want to keep it on S3. And we can actually do that with partitions. Because we put it into a bucket, I can do some pretty cool smart things in the Hive Metastore and say, well, the last 3 days or the last 3 months, I'm going to keep it locally. And for everything past that, I'm going to actually save that on the cloud. And so it does solve two really important problems with this. I can actually have my data locally on the computer, do my Spark, and do all the fun stuff that I want to actually do on my cluster. At the same time, I have the problem that my cluster is growing with data. It's got 5 years, it's got 120 terabytes, and we can't afford it. I can put 80 of those terabytes in the cloud and only use 3 months. And for someone trying to run a business, that is invaluable. It does another really cool thing is that I'm a firm believer that your Hadoop cluster should not scale with volume. Just because your data is growing and growing and growing doesn't mean that you have to have more and more computers to process that data. You should grow your cluster on compute. It should not be storage. By doing it this way, you only have a fixed amount. I get a new data source. It's the ARB. It's a tax file number, whatever your data source is. And I know that it will only have 3 months worth of data, and I can fixed cost that, and it's pretty cool. What if they're missing? So a few cool things that you can do if your partitions are missing. So same way that we do an MSCK, we can find those partitions. So putting it all together. So you can imagine how in a data engineering pipeline, we're going to have an example like clickstream data. In this particular example, we've got a website. It could be for a broadcaster, it could be for Netflix, it could be whoever it is. And they're getting millions of devices and they're pumping out these log files. Who's watching what, when, why. And you can see how that's useful information that we can turn to advertising or segment, whatever we want to use it for. I'm going to collect all those log files. I'm going to load them into raw. And I'm going to put them into the buckets. And I'm going to do it every hour or every day, whatever my preferences is. I'm going to do my transform and windowing function. I'm going to put it into my curated. My users, they don't care when I got those files. They care about when that event happened. Sometimes there's a delay. Sometimes people have bad connection. Some people are offline and those files get submitted later, the next day, because of your caching or whatever reason. And so the end user, he only cares about when did that person watch it. Was stranger things happening when that happened? So they really care about the time and they care about the destination. It was from web, it was from mobile, it was from smart TV. So we can start to see how this very generalized framework about ingesting kind of comes together. And to be honest, I've done it for a few different clients for a number of different cases. So in broadcast, we use it for creating single customer views. So we do a lot of upsets and kind of saying, well, this person, as we get new information about them, we kind of do the upset to kind of collect them. Golden records, as we get new data sources, we can replace the source of truth. Scoring algorithms, I kind of want to have some history. And some Spark applications. Well, basically Spark is smart enough to know what partitions are what. And so by using partitions effectively, you can really get your Spark apps to fly. You don't want your Spark app that's supposed to be running super fast trying to scan through terabytes of data. Told you, more code. Sorry, guys. So the question that I got when I was explaining this to a few of my colleagues is, well, how does this actually work? It's basically like creating a folder and moving the files into that place. So the first script, all it does is saying, well, I need another folder or another bucket. And the second thing is I'm going to move that file into that folder. And so here I've said that it's for that particular day. I've created that folder and say put it in that folder. The second thing is that if I'm doing it into my curated, I kind of want to do it a bit smarter. I don't want to have to say, well, force it. If it's by color, I want to say just put everything into curated, and by not specifying the load date or the color or the column that you've picked, it's naturally going to do that shuffle and sort that we saw in the first video. So that's called dynamic partitions. So basically for S3, we can change a whole bunch of stuff. You can either do it when you create the buckets or when you want to change it. So the first one's creating it. The second one is saying, well, I actually want to change it. I don't want it on my local anymore. I want to get rid of that file from yesterday and I want to put it on the cloud. Who's had the problem of Hadoop where you had to clean up your data and you've got rid of the folder, but you left the files there? So I love just setting, like if it's an external table, you can add. Those who know this is cool. And so the final thing that I want to talk about is like, well, last little hack that I kind of use on a semi-regular basis is that, well, my partition, remember it's a virtual card, it's got to go at the end. Instead of, if I've got 150 columns about everything that I know about the web browser and all the columns, if I want to partition on the event date, I want to take it out. And instead of rewriting that code a lot, I can use this pretty cool regex thing. And what it does, it says, get rid of that column and put it at the end. And people who do data engineering every day, like, it saves me so much time. People I've shown appreciate it, so I thought to share it. Anyway, so in recap, so as a data engineer, the most important thing is focusing on how you're going to engineer your data, who's going to use it, and it's always about who's going to query that data. Use partitions where possible. If you're analyzing data, use partitions. It's going to prune, it's going to help your queries. Upserts on Hadoop, please speak to me after. I'm happy to explain it a little bit further. Powerful tool. I do it in a few cool things. And S3 is your friend for both raw and curated. Thank you, everyone. My name's Adrian. I'm from a company called Contexti. I've got some of my engineers here as well, so if you've got any questions, shout out. Otherwise, thank you very much.